In the last section, we went through a very long-winded demonstration of exactly what was happening inside of our local node. Now, at this point in time, our understanding of the Kubernetes architecture is kind of limited to this diagram right here and a couple of discussions about, some networking stuff and nodes and blah, blah, blah. Very simple, straightforward stuff. So in this section, I want to change that in a big way. We're going to walk through the process of exactly what happened when we fed that configuration file into kubectl and get a better understanding of what is kind of happening behind the scenes. Now, before I do, I want to give you a very quick demonstration at my command line, and I want to show you something rather interesting, okay? So I'm going to flip over to my command line. Now, some of these commands you are not going to be able to issue successfully. If you run the commands I'm about to run, you will see an error message. So please don't try to run these, just follow along visually for a second. I will show you how you can run these commands in just a moment as well. But for right now, just watch. Okay, so I'm going to first start off by doing a kubectl get pods. That's going to list out the current status of our running pod right here. And as you can see, it currently has restarts of 0 and an age of 1 hour. Now I want to do something very interesting. I'm going to execute a command. You're going to see a Docker PS right here, and you're going to see that I'm running a tremendous number of containers right now. One of the containers I am running is the multi-client image. So this is the container that is running inside that pod right now. Now I'm going to take that container ID. Again, this is a container that's running inside that pod. I'm going to take the ID, and I'll do a Docker kill with that ID. So this is going to completely kill that running container inside of that pod. So that's it. It is done. It's gone. Now I'm going to do a Docker PS again. If I scroll all the way back up, you're going to very quickly see that it looks like, hey, wait a minute, it's still there. There's Stephen Grider multi-client. That is the container running inside that pod. But you'll notice that the thing was only created 2 seconds ago. If I also run the command kubectl get pods, you'll notice that there is now 1 restart reflected inside of here as well. And so the thing that I wanted to demo to you here very quickly, that's going to kind of play into the diagram that we're going to look at in just a second, is that it appears that if we manually delete, or if one of those containers inside that pod crashes, it appears that it automatically gets restarted for us, for free. So with that in mind, we're now going to look at a rather complex diagram. We're going to walk through the process of what happened when we deployed, or applied, I should say, these 2 configuration files. Now, just a quick disclaimer, this is going to be a rather long video as we go through this discussion. So, I don't know, pause it at some point and take a break if you feel like it. I don't know. Okay, so this diagram, super boring, not enough detail. I want to look at this right here. All right, so this is a little bit more realistic diagram. We're going to walk through this thing step by step and see what happens when we deploy one of those files. Now, on the right-hand side, you'll notice that I'm reflecting 3 separate nodes. Remember, a node in the world of Kubernetes is a computer, or essentially a physical computer or a virtual machine that is going to run some number of objects that we create inside of our cluster. You'll notice down here at the bottom center, I have something labeled called the master. On the left-hand side over here, we've got a deployment file. So the deployment file is essentially identical to the 2 files that we just put together that create a pod or a service. And then finally, up here on the top left-hand side, I have the Docker Hub that lists a couple of the different images that we have created throughout this course. So let's walk through a series of actions now. We're going to start off with our deployment file down here. Now we're going to imagine that rather than creating a single instance of the multi-client image or multi-client container, maybe we have a deployment file that instead says that it wants to create 4 copies using the multi-worker image. So we're just going to imagine, for the sake of discussion, that we slightly changed our deployment file. We're then going to imagine that we take this file and we feed it into the kubectl apply command. Remember, that is the command that we use to load up the 2 files that we had previously put together, the client pod and client node port. So when we run this command right here, the file is taken and it is passed off to something called the master. Now on the master, there is a variety of different programs, 3 or 4 in total, that control your entire Kubernetes cluster. So there are 4 programs in total, but you and I are just going to kind of imagine for right now that there's just one program called the Kube API server. Again, 4 programs. We're just going to kind of consolidate it all down to 1. The Kube API server program is 100% responsible for monitoring the current status of all the different nodes inside of your cluster and making sure that they are essentially doing the correct thing. So we're going to imagine we take this deployment file and pass it into the master. KubeAPI server is going to see this new file. It's going to read the configuration file, and it's going to interpret it in some fashion. The master then has a little kind of notepad of sorts that records all of its responsibilities, or essentially all the things that you and I have told it to do in the form of these deployment files. So when we feed in the deployment file, KubeAPI server is going to look at that file, and it's going to see, oh, all right, the developer wants us to run 4 copies of multi-worker. And so KubeAPI server is going to update its little list of responsibilities and say, okay, I need to be running an image called multi-worker. I need to be running 4 copies of it, and right now I am running 0 copies. So KubeAPI server is going to update its little list of responsibilities right here, and it's going to say, oh boy, I need to be running 4 copies, and I'm currently running 0. Well, that's definitely bad news. So what's going to happen? KubeAPI server is then going to reach out to the 3 different nodes that are running. And it's going to say to each of these, hey, people, look, we got a big problem. We need to be running 4 copies of multi-worker, but right now we are running 0. So you 3 nodes, I want you to start up some number of copies of multi-worker. It's going to say to the first node down here, I want you to start up 2 copies of multi-worker. I want you to start up 1 copy. And I want you to start up 1 copy as well. Now, inside of each of these nodes, there is a copy of Docker running. That's right, a copy of Docker running inside of each of these virtual machines. That is true of the virtual machine that is running on your computer right now with Minikube as well. So technically, on your computer, you now have 2 copies of Docker running. Both the copy created by Docker for Windows or Docker for Mac, and the copy that is running inside of that single node that has been created by Minikube. Now, when the master down here says you need to create 2 copies of multi-worker, 1 copy, the copy of Docker inside of each of these different nodes is going to spring to action. It's going to reach out to Docker Hub, and it's going to find the multi-worker image right here. It's going to copy or download that image and store it on some local image cache inside each of these nodes. Now, the thing to remember here is that each of these copies of Docker are 100% kind of autonomous, not connected. So they're all going to reach out and grab that, oops, not multi-client, but multi-worker image. And so you can kind of imagine that we get the multi-worker image inside of each of these nodes like so. Then each node is going to use that image to create a new container out of it. So we're going to create 1 copy of multi-worker as a container. We're going to make another copy down here. And then we had said that this last node would make 2 copies of the container like so. Now remember, technically each of these containers are being ran inside of that pod interface, or that pod object thing. But for the sake of this diagram, we're just going to say, yeah, the containers basically exist, but they are inside of pods nonetheless. So now that each of these have started up a copy of multi-worker, the master is going to reach back out to each one of these nodes, and it's going to say, okay, need a status update. How are things going? It's going to look at the first node. It's going to see, okay, 1 copy. It's going to look at the second node. Okay, 1 copy. It's going to look at the third node. Great, 2 copies. So in total, it now has 4 copies of multi-worker running. And so it goes back to its little list of responsibilities of sorts over here, and it's going to say, I now have 4 copies of multi-worker running. And at that point, the master says, all right, that's pretty much it. I'm going to sit back and relax because I've done my job. So that's pretty much the entire flow. Now, the last thing I want to mention is what happened when I did that docker ps command over here. And then you'll recall I killed that running container with docker kill on this ID right here. So what exactly happened there? Well, just a second ago when I said, oh yeah, the master sits back and relax, well, that's not what really happens. You see, the master is always continuously polling each of these different nodes. It's watching every single one, and anytime that something happens inside one of these nodes, the master gets a little notification. So we can kind of imagine that when I ran docker kill, and then I killed that container, we can imagine that one of these containers essentially fell away, like so. So the master then got a little notification that said, hey, little issue here, one of our containers just up and died, completely gone. And so the master very temporarily updated its little list of responsibilities to say, okay, I need 4 copies of multi-worker, but I now have 3 copies running. Whoa, that's a big problem. So the master then looks back out at its collection of nodes, and it says, maybe it picks this node right here and says, hey, you need to have an additional copy of multi-worker running. And so this node right here will use that image that it's already downloaded, and it'll create a new container out of it. So multi-worker container. And then it reports back to the master and says, hey, we're good. I just started up another copy. And so the master says, great, I now have 4 copies running again, and I am plenty happy. All right, so that is the full flow. That is what is happening behind the scenes. Now, some of the big takeaways that I want you to understand here from all this stuff. First off, when you and I loaded up that deployment file, we did not pass that deployment file directly off to one of these worker nodes. Instead, the deployment file went to the master. So the big lesson here is that you and I, as developers, work with this master. You and I do not work directly with the nodes over here. In other words, you and I are never going to reach into a node with some series of commands and attempt to manually start up a container inside of one of them. Instead, we're always going to use the kubectl command line tool, which is going to send all of our commands off to the master. It's then up to the master and the different programs that are running inside this thing to reach out to some appropriate node and create the appropriate container, or essentially update the state of, update the appropriate container, update the appropriate node. It's up to the master to reach out to some node and tell it to do some amount of work to fulfill the master's little list of responsibilities. The next big thing to take notice of is that the master is always watching each of these different nodes. Anytime that some container, or some object for that matter, runs into some issue, the master is going to automatically attempt to recreate that object inside of some given node until its list of responsibilities is 100% balanced out. Now that kind of idea of us kind of saying, hey, master, here's your list of responsibilities, and then having the master constantly work to make sure that that list of responsibilities is fulfilled is one of the most important ideas in everything around Kubernetes. Yes, just as important as that other thing I said was really important, the networking stuff. Yeah, there's a lot of important stuff. You get the idea. But in reality, or all joking aside, the idea of the master constantly working to fulfill this list of responsibilities right here is very important. So we're going to take a quick pause right here, and we're going to have a real quick discussion. I'll make it as quick as I possibly can, I promise, about how we interact with Kubernetes in general, and how we approach this idea of having the master kind of have this list of responsibilities that it needs to fulfill. So quick pause right now. We'll come back to the next section, and we're going to expand on this idea around the master.